Man, thank you, Kyle, for the invitation. I'm glad to see everybody in this event. So my talk has to do with variable rate technology, but I try to focus only on the zone management or how to define zones that can be managed individually. So it's a lot of fertility management in the topic, and there's also some other areas that I want to point that we're doing in Arizona. Okay, so with this, I want to say, well, the presentation is really three parts, and I'm going to go relatively fast. Doesn't need to go in a lot of detail. There will be some concepts. We'll have some examples, and then we go into the online options that I referred to. But second part is it's important to understand what is the difference between something that you have available for free, that's number three, and what is something that you need to invest to obtain that information. And as we go with this presentation, I like I asked the audience to think about these four bullet points that had to do with what are the factors limiting adoption of zone management in Arizona specifically. Are there more machine related? Are there more into the digital interface, economics, anything else? So your comments are very valuable to me. So please keep that in mind, and even through the chat or at a later time, we can discuss that. So starting with some background information. This slide, the point of it is to say variable rate or zone management, it makes sense from any perspective. And even as far back as 1929, there was this paper that all they did was to set a grid sample. They determined the needs of line. This is in the Midwest. And they say, okay, well, these are the zones to be defined, 1929. So there was no technology back then that can make this possible. But I guess the point is evident and logical, right? So we start from that base. It's a logical step. Okay, so now getting a little closer, in the mid 80s is when we first saw the implementation in the field of variable rate technology. So and one of the first ones was zone management for fertility in the Midwest. Okay, so it is considered as the first technology built on that site-specific basis. Then, first project ever to be done in the United States about variable rate technology was called Farming by Soil Types out of Minnesota. So this was in the mid 80s, and it was very interesting. I want to point a couple of elements that are important. First, it was a private partnership, and the technology side of it was being built by Soil Tech, a commercial setting, and a chemical distributor in Minnesota. Okay, so that I found is a very interesting element that the private sector was there right at the beginning. Um, but more important is to take a look at this picture on the right. That was the sprayer that they were using, the spreader that they were using, and you don't see a whole lot of detail, but that was very, very, very complex. Wires everywhere. I had the fortune to know I worked for one of the um, researchers involved in this project, and he was describing to me how they had to take floppy disks to the field, inserted them in a computer, and but it was the beginning. It really they set the basic principles on how to handle spatial data. But back to the point that is two private companies, Soiltech is no longer in business. So, and I found, well, now we're seeing everywhere these technologies, and one of the pioneers that took a lot of the risk, they disappear as an entity. Maybe they morphed into something else. Okay, so now I want to go into definitions, but I don't want to do this from an academic perspective. I rather use words that are common for growers, and in this case, this is a crop consultant company, very large in the east. And first, a zone is a group of like areas in the field that respond to inputs in much the same way. So that's the homogeneity inside every zone. Managing high yielding fields in the same as low yielding fields doesn't make sense. That is the logical component of this. And then I really like the third paragraph. It says most of us recognize areas within fields that respond differently. You can read the rest. The point here is that growers, crop consultants, the people doing the field work, they recognize those zones, right? It's in their memories. It's in their years of experience. So one point to me is how can we digitize that experience and then make use of it? All right, so now let's go a little closer on Arizona cases. And the first point that I want to bring is areas where we see now a very strong presence of or where we see the largest potential for variable rate fertility management, of course. So this is the same spreader that I presented in my first slide. It's an air spreader, twin beam type of spreader, high flotation, excellent for soils that have moisture, like what we have in Arizona and Yuma when they have to work out the field between crops. GPS auto steer, great. So they can plan their missions and they can go fast. Productivity is really high. This is for, you can see 40 acres an hour for the conditions that are written there. It's a lot of material handling capacity, very large. In terms of rate control, so the rate controls are determined or it's based on hydraulic motors. They are the drivers, and they're sensor controlled. That's the reason why they can change rate from 20 to 800 almost instantaneously, because it's based on changes on a motor speed, and those happen instantaneously. They're metering in the individual metering at 4 points in that spreader. So 2 on the left, 2 on the right. There's turning compensation. There's driving controller compatibility and other, perhaps by now with other displays. The point is, such a large machine with tremendous capacity and advanced control, why is it that it's not being used more often in variable rate mode? So that I'm posing the first question in this presentation. Now, let's take a look at some other examples where we are working now at the University of Arizona. In precision planting, there's a lot that we can say after 2 years working with precision planting. So we're working on variable seeding rate, the capacity of these electric drives to change the rotational speed of the plate, and that's how we get variable seeding rates. Downward pressure, that's another factor that we're working on, and variable depth is a new concept that we are exploring in 2021. So when you think about variable rate technology, it's not only fertility. We're looking into other areas like planting, and we're also doing work on pest control. In this case, there's this image of sensor controlled spot spraying. There are 2 companies making these products available. And one of the very good things about this is these are coming now with pulse width modulation for rate control, because orifice plate is not physically very difficult to change the flow, but with pulse width modulation, it's pulsations, so we can do that. Okay, now a couple of examples where variable rate is enabled by sensors. And this is the case, again, that there's some investment, some cost involved in generating the basic information. So here we see work of Randy Norton. He worked on site-specific management of cotton root rot and the injection of the fumigant. Okay, so it starts with a survey with electrical conductivity in bulk electrical conductivity sensor, like the picture in the top left. And then he develops these maps. From that map on the left, that is soil electrical conductivity, we then create a map that is on the right, which we integrate that variation. At that point, it is very easy to determine each zone or each color to have a different rate. In the specific case of Randy, I put a red line there. Approximately, that is on a threshold. So any area with electrical conductivity below 20 millisiemens per meter will be injected with fumigant because those are the lighter textures of the field. Anything above does not need because it is expected that the population of these nematodes is going to be very, very low. And a quick picture of the system that he used to do that injection. Okay, something that we worked in 2012 in Sacaton, Arizona. So we were mapping yield on durum wheat. And you see the picture of our 1970s combine, state of the art back then, the actual flow combine. And then, but we retrofitted with you see in the picture on the bottom left, that is a force transducer that measures the impact of the grain in the elevator as it's moving to the bin. So that is how we measure yield, and that's the map on the right shows the passes that we went back and forth, harvesting and collecting that information. And you can see how clearly there are zones there that perform differently. So this is just, again, one example. The map on the left, it's just an interpolation classifying yield in 3 different categories, right? From 300, which will be very, very low, to about 6,000, then 6,000 to 600 and 6,700, and then anything above 600 to 6,700. So that is just a map. But having that digital map allow us to very, very easily manipulate this information and then do rates. In this particular example that you see on the right, that screenshot, it was just an exercise where we calculated not to fertilize this field with more amount total, but rather to redistribute the total amount in different zones. And you can see the details there, ranging from 25 to 31, so 3 rates. And this is a redistribution. There's no overall fertility fertilizer savings. It's just redistribute with the intention, with the goal of having higher yield in the field. So finally, now let's go to the free stuff. I like free things, and I think everybody does. And there are 2 examples I want to provide to you that I found very powerful. It's open access to everybody, and I think it's an excellent first step for somebody that wants to explore variable rate in zone management. And by the way, these solutions are getting better and better every year. So let's start with Google Earth. There is the Google Earth Pro. It's, again, free. You can read a little bit of information on the right. It says you can create maps. You can do import and export GIS data. In this context, basically what they're saying is that you can bring in and export out shape files. Then every display in a tractor or sprayer will interpret. Okay, and the other is the history on time. All the imagery that they have collected over years, starting approximately around 1996. You'll see that that is a very useful feature. Okay, so let's take a look at one example. This is the same field captured on Google Earth on 3 different dates: 2006, 2014, 2016. It's the same field. It's 2 of those are in August, 1 in November. Okay, so sometimes you get a imagery that happened in the spring or happened in the fall, and you'll see very different images because of what crop was grown there. Now, what I want you to see is that this is a field with a very high soil variability. Okay, it's evident in the northwest corner. It is much higher productivity than in the southeast corner. Okay, so the map on the right shows you a polygon, that white boundary that was made completely arbitrary with the click of the button in my computer. I had full control where I want to draw this particular polygon. Why that is important is that that polygon can be then exported as a shapefile, and then you can manipulate, you can add rates based on that. Like in this case, you can easily do a high rate and a low rate. Okay. Next example of online resource, and that is the soil survey from the NRCS, free of cost. What they did is that they digitized the whole United States soil survey. I've seen in libraries the books that correspond to the hard copies that are for all the soil survey in the United States. It's just a collection, a very, very large collection. Well, the good thing is that is in digital form, is geo-referenced, and has this imagery background, very easy to locate your fields. So this is an excellent resource. So what you do, hold on, let me go back. You see a map here that's trying to capture the major areas of Arizona, the growing areas of Maricopa, Yuma, and places relevant to us. So you can zoom in, and then you can find your fields very, very easy. So zoom in, zoom out exercise. So I am looking at the same field as I presented a couple of slides ago, where I defined the area of interest on my control. Click of the mouse, boom, you have this area defined. And then I asked the software, the online software, to give me the soil survey units for that particular field, only for that area of interest. That's the image on the center. And the image on the right tells you that after that, you have your field in a shapefile format that you can manipulate any way you want. And I'm just arbitrarily, I'm saying, well, I'm going to do like a high productivity zone in the top, in the northwest corner, and some intermediate productivity zone in the middle. I can do whatever I want. Just follow those contour lines. Okay, so that's the end of my presentation. But I have a couple of comments to make really quick. Ayman, how much time do I have?
You're already out of time.
Oh, I'm sorry. Well, let me say just very quickly. If you have access to online resources, you are 80% into variable rate. Okay, that is a very good, important message. And the other is, I listen to you guys, and I have all my ears tuned to know from you about these factors that are impacting the adoption of zone management. So I'm going to stop there.